Hello everyone, today we are going to solve a question from a Leetcode named as add one row to tree. So the question says that we have a root of a binary tree and we are having a value and a depth, and the depth represent where we have to insert the given value. So coming over my notepad, let's discuss with an example what the question is trying to say to us. In question example 1, we are having a root. Root mainly gives the address of a first element of a tree and the value which we have to insert and the depth. And the depth represent where we have to insert the value. So the here's depth is 2. And if we consider this tree, this is our input tree. So it is a depth 1 and it is a depth 2. So we have to insert the value 1 at depth 2. So the final output will be where we have inserted 1 at depth 1, 2, and the remaining 3 is same. Let's discuss the example second. In this example, we have to insert the value 1 at depth 3. So this is the depth 1, this is 2, and this is 3. So the output will be this. Okay, and one more thing in question we have given that if we are having a depth 1, if we are having a depth 1, then what we have to do is that if depth is 1, that means there is no more elements in a tree. So we have to just insert the value there. Um, we all know that when we are approaching the question of a tree, then there are two ways. First one is breadth first search, and second one is depth first search. And both are very easy if we are able to uh, conclude that how we are approaching the particular solution. So we are starting with depth first search. What we will do, let me draw the tree first. So this is the tree as an input. The one thing we are having is that if we are having a depth of one, so what we have to do, we have to just insert the value. Okay, so we have to just insert the value at the because this is the depth one, so we have to insert value here. So at every condition, we have to start that if depth is equals to 1, then what we have to do. And then we can go for the depth first search. Depth first search always first go on the left and then on the. In every video, we will start with some approaching the problem, a solution, and then we will figure out the algorithm and then we move towards the coding part. Okay, so first of all, we are discussing how we approach the depth first search in this question. So what we will can do is at first let we are having a particular function where we having a root value and depth. Okay, so the scenario will be if the depth will be 1. If depth is 1. Okay, so what we have to do is we just insert the root value. So let me have a struct as a tree node. So what I can do is I can create a temporary node in which I can insert a value, and at that node, that temporary node, at the left part, I insert the root, and I have just to return the root value. Because in this, as you can read in a question that in depth when we have there is no depth, so we have to create a node with value and we have to just give return the original root. So that's about the depth one. And then we can do this part in both breadth first search and the depth first search. Then we go for the find our function where we have to do our DFS. We can pass our root value. Then I can pass my value which I have to insert, and then the depth. Because if I'm moving downward, then my depth is decreasing. So I pass the value depth minus 5. Okay, so we are discussing now that how we approach the DFS function. So DFS function is very easy to write if you are having a little bit knowledge of how to perform a depth first search. Okay, so at first, if I'm let me write the DFS function first. This is let me take it as a depth. Okay, so the conditions we have to write if we are approaching for a recursive function. We have always write a basic condition. So the base condition here will be if root is equals to null. Okay, so if root is equals to null, then what we have to do, just return our function. Because if root is null, then we have nothing to do with it. And the condition is that if depth is 1, because we have to reach where depth will become a 1. Okay, once we reach to depth 1, then what we have to do, just creating a temporary variable in left variable, temporary left variable, in which I store the root left. Okay, in which I have to store the root left. Then I create a temporary right variable, which I store root right. Okay, and then just one thing, that the state, the root state, it root state in the left part. What I have to do is I have to insert a value, and in the root right, I have to insert the value. One more thing, what I have to do is at the value left, value become a node, and then the value left will consist the temporary left, and value right will have a temporary right, and that's it. It's the main function we have to know, what we have to write to proceed for the solution. Okay, so there is only two more recursive call that will be a function BFS, then it will be root left, and then I will pass a value, and I just decrease my depth by one more, and then I call it for the right. Okay, so the same well, I pass the value, I decrease my depth by one, and then I will return my function. Uh, Let me clear it for you once more. What I am doing is that at first I am standing right here in my main function. Okay, so I will pass the value depth minus 1. If I'm having the value 3 as a depth, and I'm standing here with the depth value 3, then I pass my value by 2, so depth become 2, and in the DFS function I will be with depth 2. Okay, their root is not null and my depth is also not 1, so I will go at first for the left recursion. In the left recursion, my depth value will be minus 1, so it will become 1. And here I'm not having a root as null, but I'm having a depth as 1. So what I will do here is that I just created a temp left and temp right. So temp left will consist 3 and temp right will consist 1. Then what I will do, this is my root right now. So what I will do, I will do that in root left, I will insert the value. root left and my value is 1. So at root left, I inserted the 1 and same as root right, I inserted the 1. Then what I have done is that at the value left, in value left, I have inserted the temporary left, and in value right, I have inserted the temporary right. So this is all about the DFS. Let me code it for you. But it's my humble request that I'm giving you an algorithm. So just go and write code for once for better understanding. If you're not able to approach the prob solution, then come back and see the coding part. So what I have, if my depth is 1. So what I have to do is that I have to create a temporary node in which I create a value with the given value. Okay. So and then at the temporary left, I will store my root one and I will return my answer. But if the depth is not equals to 1 and I'm doing a DFS, what I will go for is that I will create a DFS function. I will pass my root, the value and depth by decreasing it by once. Okay. And then I will return my, okay. So we go for creating a DFS function. So DFS function will consist a root value, the value given by a function and the depth. Okay. Here the base condition is that if root is equals to null. And if root is equals to null, I just return my value. And the second condition will be if depth is equals to 1. What I will do, I will create a temporary left and it will store the root left value. And second, I will create a temporary right value and it will consist a root right. Then I will create a root left with I am having a function here through which I can combine these 4 lines in just 2 lines. Okay, so these 4 lines I will create. You can write it like as I have written here, but in the question I'm combining this part in 2 lines. Okay, so it will be, I will pass my value, what value I have to insert, and in values left I have to insert the TL part, and in right I have to insert the null. And in the root right I create a value and in which I store the val part, and in left I have to insert the null value and at the right temporary right value. Then I just return my function. For having a DFS function, I have to call my function for the left subtree and the right subtree for both. So I will write my function here by passing the root left, same value, and I decrease my depth by 1, same as with DFS right. So it will be root right and value and depth is decreases by 1. And I will return my function. That's all about the DFS. It's a very simple question. So let's run our code. There is a error and the error is that redefining, oh sorry, I have to tr. Here I have to return the value t. So that's correct. Let's submit it. So my question is submit. Okay. Let's move with discussing the breadth first approach. So what breadth first approach do? We have to maintain a queue in which we proceed with a particular level in every group. So let me draw my queue once again. It's okay. So here we are having a depth as 2 and my value as 1. Okay. So what I will do here is for having a breadth first search, I will I will create a variable level with initial value as 1. Okay. So my base condition will be if the level is equal to depth minus 1. Okay. If my level value is depth minus 1, so depth minus 1 is here as 2. 2 minus 1 as 1. And my level is also 1. At first in Q, I'm having a 4 value. Okay. So as depth is 2 and my level is 1. Okay. So 2 minus 1 is equals to 1. So my root is this 4. And if, and if I talk about the depth here is 1 and we have to create a 1 and 1 here with value. Okay. So what I will do, my base condition is if level is equals to depth minus 1, then I perform the same work here also. I just create the temporary left, temporary right, then I will store root left value and the root right value. And in the root left and root right, I will maintain a one node with value, given value, and then I will insert 2 in the temporary left and I will insert 6 in temporary right. And if I will discuss this question, here level is 1 at first and depth is 3. So I have to go for the level 2 because 3 minus 1 is 2. So at first I will go for 2 and here my level value become 2. So after 2, what I will insert in 2's left, I will insert the value and 2's right, I will insert the value as 1. And then I will maintain root left as a node left and root right as a node right. Just see the code because it is same as depth first search, but the only difference is that we have to maintain a queue here. So just write the question. Let me clear my depth first search function first. The condition of 1 remains same. What I will to do, just I have to pass my depth and it's my breadth first function. So void breadth first search will have a arguments as node, my root value and its value and its depth. Now I have to maintain a queue with a tree mode and with name queue and I will insert in queue as my root. Now I have to run my value. Let me declare first the level and it is 1 and then I will have to run my loop till my queue is empty. And the length of queue is calculated by queue dot size and then I will go for a for loop for looping over the elements at a particular level. So it go for from 0 to length and it increment by 1. Then I will take my particular node by queue front and then I have a pop. I will pop my first element of a queue so that I can move forward in a queue. And if my base condition is that if my level is equals to depth minus 1, what I have to do just is I have to create a temporary left in which I will store my node left value. Then I will have my temporary right. Then I will store in my node left with the value, and in values left I have to insert TL, and in values right I have to insert null. Then I will go for inserting the node right value, and it will be a value, and in values left I have to insert null, and in values right I have to insert my temporary right value. Then if condition is completed, and then I have to check if node right is node left is present here or not. If it present, then I have to insert in my queue its left value. And now I have to check for node right is present over there or not. If it is present, then I have to just push its value. And if I have done here all my maximum part, then I have to just increase my level value, because for loop will iterate over a particular level elements, and once it is completed, I have to move towards the second level. So I just increment my value here. And when my all functions are completed in my breadth first search, I have to just return it. It's not code. So it is right. It's check if it's an array submitting or not. So it is accepted completely. If you still have any doubt, please comment below, and don't forget to like, share, and subscribe my channel. Thank you guys.